All right, 3.3 rules of for differentiation, part B. We're still going to use regular basic derivatives, the product rule, the quotient rule, and I think there are some higher order derivatives. I don't remember. Okay, example 1, rewriting functions. Sometimes it's not necessary to use the quotient rule. For example, in these two problems, they are fractions, but I can actually rewrite the equations first, and I won't have to do the quotient rule, and it's a lot easier. So you have to kind of train your eye to see where you can rewrite and avoid the quotient rule, and when you actually have to do the quotient rule, because there's no way to simplify the problems. Okay, so I'm going to rewrite first. So I'm going to break this up, x squared over 6 plus 3x over 6. And hopefully you can see that I can simplify the 3 over 6 part. And then the x squared over 6, if you feel comfortable still separating the 1/6 from the x squared, that's fine. So I get 1/2 and then x. So that's what I'm going to derive. So my derivative, y prime, or dy dx, whichever you prefer. So I'm going to bring the 2 to the front. So 2 times 1/6 x, and then subtract 1. So it stays as 1. Plus the 1/2 x. Remember, this has an exponent of 1. So if I bring it to the front, that's 1 times 1/2. And then the x, right? But then if I subtract 1 from it, I get x to the 0 power. And what is x to the 0 power? X to the 0 power is just 1. So basically, this is one big fat 1. So 1/2 times 1. So do I really need the 1? No, I don't. Okay, please remember, if it's just a lonely x, the coefficient, or whatever number's in front, that's what's left over. So here's my derivative. I could simplify this to 1/3 x plus 1/2. All right, b. So I'm going to rewrite again. So let's see, rewriting here, I'm going to distribute the -3. So negative 9x minus 6x squared. And then the 7x in the bottom, I could split it up. So this would have its own denominator, and this term would have its own denominator. Now by doing that, I see stuff. For example, the x's cancel each other out there. And then on the right side there, there's an x on the bottom and there's an x squared on top. So I can get rid of 1 from the top and the 1 from the bottom. So now I have negative 9 over 7 minus 6x over 7. I split it up. All right, so derive. So let's call this one dy dx, just to change it up a bit. Negative 9 over 7 is a constant. Constants become 0. 0 minus, okay, negative, or, well, I already wrote the minus. 6 over 7x, that just leaves 6 over 7. So, of course, my answer is just negative 6 over 7. I don't need the 0. Okay. Example 2, working with numerical values is really, it's not that difficult, but you have to understand that I don't have any equations in this problem. Example 2, let y equal u times v. So y is a function where u and v are being multiplied. Be the product of the functions u and v. Okay. Find y prime of 2. That means I'm going to find the derivative, and I'm going to plug in 2. Now, they tell me u of 2 is equal to 3. U prime of 2 is equal to negative 4. V of 2 is equal to 1. And v prime of 2 is equal to 2. And this is supposed to be a comma. Yeah. Okay, so notice I don't have a function to derive. What I have are the values with the 2 already plugged in. Now, that's what they wanted me to do anyway, right? Here's my 2. Here's my x equals 2, or whatever variable you want to use. So what they did was they plugged them in already. Okay, so y is u times v. So that means y prime is going to be the product rule. So u times v prime plus v times u prime. Okay, so I don't actually have a function to derive, but I know what the functions equal with the two already plugged in. So I'm just going to go ahead and use those numerical values. So for example, u, right? Okay, u is equal to 3. So 3 times v prime, okay, v prime, where is v prime? It's over here, it's equal to 2, right? So times 2 plus, okay, now v, let's see, v is 1, so 1 times u prime, and u prime is negative 4. So negative 4. Okay, I just took the numerical values and I plugged them in instead of the functions because I don't have an equation. I don't have equations here anyway. So now just simplify. 3 times 2 is 6. Negative 4 times 1 is negative 4. So I get 2. Therefore, y prime of 2 is 2. And we did this numerically, no functions involved, because they gave me some information. Sometimes, instead of listing the information like that, they will make a table and let's see, they'll tell you x is 2. I need some more lines. And then they'll do, okay, so here's u, or they'll tell you u of x, or whatever. U prime, v prime, and then instead of listing them out like they did in this problem, okay, so u of 2 would be 3, u prime would be negative 4, v would be 1, and then v prime of 2 would be 2. So sometimes they'll list it in a table like this. Sometimes the tables are longer. Here they just listed it. Okay. All right, example 3. Suppose u and v are functions of x that are differentiable at x equals 3, and that u of 3 is 6, u prime of 3 is negative 1, v of 3 is negative 2, and v prime of 3 is 4. So same thing as before, no function. I just have the numerical values. Find the values of the following derivatives at x equals 3. So I've got 4 different problems basically. So A, that's u times v prime, or u times v. So it's u times v prime plus v times u prime. So once again, you just get the numerical values. U is equal to 6. V prime, if I look, is equal to 4. So now plus v, which is negative 2, times u, which is 6. Okay, so I got these u, this is v prime, this is v, and this is u prime. Oopsie, I totally forgot to write the little apostrophe. That definitely changes it, right, to negative 1. Good thing I checked. Okay, so now 6 times 4 is 24. Negative 2 times negative 1, that's positive 2. So my answer is 26. All right. Next. B. B is u over v. So that's the quotient rule. So let me go ahead and just write it out like the quotient rule. Low d high minus high d low over low times low. Okay, so now I'm just going to plug everything in. V. Look up on my list. V is -2. U prime. Look up on my list. It's -1. Minus U is 6. Minus V prime, or sorry, times V prime is 4. And then V was -2, so squared. All right, so -2 times -1, that's +2, minus 6 times 4, that's 24. -2 squared is 4. I can simplify that. I get -22 over 4. And technically I can simplify that. In this class though, not really necessary. -11 over 2. -22 over 4 is a valid answer. Alright, moving down to C and D. Okay, C is V divided by U. Now, okay, I realize that the letters have changed on us, but the rule stays the same. It doesn't matter what the functions are. So in this case, the U is the low part, and the V is the high part. But my formula stays the same. It's low times the derivative of the high minus the high times the derivative of the low over the low times low. Okay, it looks different, right? Because they switched the letters on us, but the formula stays the same. So now I plug in stuff, and I can't see my values anymore, so I'm going to look on my paper. Okay, so U is 6 times V prime, which was 4, minus V, which is -2, times U prime, which is -1. And this is all above U squared. So U was 6, right? Yeah, 6 squared. Okay, I need more space. Okay, so 6 times 4, that's 24, minus -2 times -1, that's +2. And then 6 squared is 36. So I get 22 over 36. Not necessary to simplify, but whatever. 11 over 18. Okay, D. Same idea. Here's my function. They're telling me that 5 times U plus 3 times V minus 2 times U times V. So I have to derive this. Okay, so once I derive this, and I'll just start right there. Once I derive this, I get 5 times the derivative of U, whatever that function was, I'm going to derive it, and it's 5 times that, plus 3 times the derivative of V, because whatever the function V is, I derive it, I call it V prime, minus 2 times, so this is a product rule, U times V. So 2 times U times V prime plus V times U prime. And I'll put it in parentheses to make sure that I remember, oh, that 2, I need to multiply everything by 2. Okay, so I need to look at my paper again. 5 times U prime. U prime is -1. Plus 3 times V prime. Okay, so V prime was 4. Minus 2 times the derivative of the product rule there. I'm just going to leave that in my parentheses. And, all right, so U, all right, let me look. U is 6 times V prime. V prime is 4. Plus V, let's see, V is -2 times U prime, which is -1. All right, let me simplify. So 5 times -1, -5. 3 times 4, that's 12. Minus 2 times whatever I get in here. So let's see, 24 plus 2. All right. Well, 24 plus 2 That's 26. I'm multiplying that by 2. And then I have negative 5 plus 12, which is 7. So then 7 minus 2 times 26, which is 50. Holy crap, brain dead. 52. So 7 minus 52. And I get, wow, brain dead for real. Negative 45. All right, example 4 leads us to negative exponents, but before I start, I want to remind you guys, just in case you managed to forget, I hope not though, when I have an exponent that looks like this, right? That's a fraction. The denominator has the exponent. I can rewrite that as x to the negative 2 power. Any negative power actually means that your answer is basically a decimal or a fraction. So that's a reminder. Okay, we're going to rewrite these. Negative exponents, they're not any different than regular exponents. I'm still going to subtract one, but I'm going to rewrite it just so that, you know, we don't get confused with all the fractions everywhere. Eventually, I hope, though, you don't have to rewrite this. So I'll write it over here. Okay, so this is going to be 1/3 x to the negative 6 power minus 1/2 x to the negative 4th power plus 1/2 x to the negative 2 power minus x to the negative 1 plus 5. Okay, so maybe that'll help you see better. All right, I'm going to derive y prime equals, just like before, bring the negative 6 to the front. So negative 6 times 1/3. The x is there. I'm going to subtract 1, so now I end up with negative 7. Minus, right, bring the 4 to the front, but it's a negative 4. So this becomes plus, and there's my 4 times 1/2 x, subtract another exponent. All right, plus x to the negative 2, but I'm going to bring the negative 2 to the front, so minus 2 times 1/2 x to the negative 2. Okay, proceeding. That negative 1, I'm going to bring it to the front, which makes that minus a plus x, and then subtract 1, and then the 5 is a constant, it becomes 0. I'll write it down. Okay, it becomes 0. All right, then simplify. So let's see, negative 6 over 3, that's negative 2, x to the negative 7, plus 4 times 1/2, that's 2, x to the negative 5. 2 times 1/2, that's just a 1, so x to the negative 2 power. And then plus x to the negative 2 power. Oh look, there's 2 negative 2's, unless I forgot to do something. Oh crap. Oh, I did. Alright. So, of course I did. This negative 2, I was supposed to subtract 1, making it a 3. My bad. Alright. So, I'm done. Nothing else to do. They're negative, but it's the same process. Okay, B. Same idea. Here, though, I didn't actually write out the negative exponents. They're already in the denominator. So C's are just easier if you go ahead and rewrite. So 5/2, I'll split that up, and then x to the negative 3. Instead of leaving it in the denominator, if you write it as an exponent, a negative exponent, it'll be easier to do the differentiating. So minus, and then 1 over x squared just becomes x to the negative 2. All right, so that's my function rewritten, my equation. So now I get to derive. All right, y prime. Okay, 4x cubed plus, okay, so I'm bringing the negative 3 to the front. So negative 3 times 5/2 x, and then I have to subtract 1. Okay, next I'm bringing the negative 2 to the front, so that minus is going to become a plus, and then x, and then I have to subtract 1. So 4x cubed minus 15 halves x to the negative fourth plus x to the negative third. Sometimes on the multiple choice, your answer will not be written out like this, in which case you're going to have to revert back to writing negative exponents as denominators. Sometimes, not always. So minus 15, and then the 2, and then the x is going to be down here, but notice the exponent is now positive. Plus 1 over the x to the positive 3. So sometimes you'll actually have to revert back to fractions. Not always. Okay? All right, example 5, equation of a tangent line. Find an equation for the line tangent to the curve y equals x squared plus 3 divided by 2x at the point 1, 2. Okay, so remember, to write an equation, you need two things. You need the slope, and you need a point. Here's my point. Slope is the derivative. So I always tell you, or will always tell you, this is the formula we're going to use to write the equation. It is the friendliest one. But first I have to find the derivative. So y prime. Let's see. Oh, that's a fraction. Okay, dokie. So let me get my pieces. U is the top, x squared plus 3. U prime is going to be the derivative of that, which is 2x. V is the bottom, which is 2x. And then v prime is going to be 2. So there are my pieces. If it helps, let me write this out. V times u prime minus u times v prime over v squared. All right, so let me plug in the stuff. V is 2x. U prime, oh, 2x. How convenient. Okay, minus u, which is x squared plus 3. X squared plus 3 minus, times v prime, which is just plain old 2. And then all of this over v squared. Okay. Now, you could simplify this if you wanted. But the thing is, I need a numerical value for the slope. I'm not just looking for an equation that is slope. I'm looking for what does the slope equal. So, you could actually stop right here and then go ahead and plug in the x. Okay, x is 1. So you don't have to simplify this. And sometimes you won't want to. Some of these equations can be horrifying. This one's not so bad. But I can go ahead and just plug in the 1. So I get 2 times x, which is 2 times 1, so 2. And then 2 times 1, which is 2, minus. All right, plug in the 1. I get 1 squared plus 3, which is 4. And then that times that 2 that was already back there, over. Okay, 2 times 1 is 2, and that's squared. So I get 4 minus 8 over 4. So negative 4 over 4. I get negative 1. My slope is negative 1. Okay, you do not want to simplify if you don't have to. Please. We make mistakes when we simplify. Sometimes. Okay, so now I have my slope. Right, that's what this is. Slope. The derivative is the slope. And now I can just use my point. Right? And I can write the equation. Okay, so y minus 2 equals my slope, which is negative 1, times x minus 1. Okay, distribute the negative 1. I get y minus 2 equals negative x plus 1. And then add 2 to both sides. I get y equals negative x plus 3. And here's the equation of the tangent. All right, horizontal tangents. Remember, horizontal is left to right. So whenever I have a horizontal tangent, my slope is 0. Okay, so example 6. Find the points on the curve. You can see it. It's long. It's there. Y equals whatever, 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 where the tangent is parallel to the x-axis. Okay, so parallel to the x-axis. Refresher, in case you don't know what I'm talking about. Here's the coordinate grid, basically. This is the x-axis. This is the y-axis. In order for a line to be parallel to the x-axis, it's going to have to be horizontal, right? Because the x-axis is horizontal. So basically what they're asking me to do is to find the point on this curve where the slope is 0. In order to figure out where these points are, my slope has to be 0. So my slope is the derivative. So I'm going to derive 3x squared plus 11x minus 4. And that is my derivative. So I'm going to set it equal to 0. 3x squared plus 11x minus 4 equals 0. And then I'm going to factor this out. And I'm going to figure out where are these points where my slope is 0. All right, so I need two numbers that multiply up to negative 12, but that add up to 11. So I have 12 and negative 1. Okay, now here, this number right here, whenever you factor out and that number is bigger than 1, or basically not 1, then you have to divide by it when you find your factors. So I have x plus 4, and then x minus 1/3, but normally we don't leave it as the fraction. So I'm not going to, even though in this case you could, because it'll save you a step, but I just can't. I can't do it. Sorry. Okay, so zero product property, x here equals negative 4, and the x here is going to equal, oh yeah, 1/3. So there are my points. This is where my derivative equals 0. At x equals negative 4, and at x is 1/3. Okay, so at these x values, the slope is 0, but I have to be careful, because if I read the instructions, it says find the points. And points are x's and y's. So all I got are the x's. So what you're going to do is, you're going to take the original equation, and you're going to plug in these x's. So negative 4, and I'm going to plug in 1/3 into the original, and you're going to get your y values. So I get 47 when I plug in negative 4, and for 1/3 I got 6.315, rounded to 3 decimal places. So officially my answer is, or my answers are, negative 4, 47, and 1/3, and 6.315, officially. All right, example 7 is basically what we just did. The words are different, but I want to do this graphically because in this class you do actually have to know how to read a graph and do things with the calculator in the graph. So the graph of y, and you see that really long equation, has 3 horizontal tangents. So there are 3 places where the slope is 0. At what point do these tangents occur? I should probably say at what points. But anyway, at what points do these tangents occur? Okay, so we're going to do this with a calculator. So here, voila, a calculator. You're going to graph the function. Y equals, oh, I always forget to put the marker down. Alright, so y equals, I already put the function in, right? It's already there for me. I'm going to graph, and there's my graph, and actually I'm just going to slide it over this here. Okay, so here's my graph. You have it on your page already. And the slopes are going to be 0 everywhere that I have a minimum or a maximum. So right here, at this point, and at this point, whatever those points are. Okay, now one way to do it is to, with your calculator, you're going to go to second calc. I keep doing that. Okay, second calc. Thank you. And see where it says minimum maximum? You can find it that way. You probably learned it last year in pre-calc, probably. So you hit 3, and it asks me a question, left bound. Okay, so I did minimum, right? So there's 2 minimums. So I'm going to go over to this one on the left. Okay, so I want to be on the left of it. Okay, is it not moving or what's happening? All right, left, enter. Now I need to go a little bit to the right of it. Enter. It wants you to take a guess, but you don't have to. Hit enter. And there it is. There is my minimum at negative 1.86224, and then the y value. Alright, so I'm just going to drag this over here for myself, just so I don't lose the numbers. There they are. Alright, and you would repeat this for the other minimum. And then for the maximum, it's again second calc. You can see all my steps here. Second calc is number 4. And then it's going to ask you, okay, go to the left bound, so the left side. So my maximum is the one in the middle there. So that's on the left, so hit enter. And then now I'm going to go to the right and hit enter. I don't have to take a guess. And then there is my maximum. I'm just going to drag this over here as well. Alright, so here are my max and my mins. Or, well, one min. I'm going to let you find the other one on your own. I already have it written down. So these are the locations of where the tangents are, or the slope of the tangents are 0. Okay, so I went ahead and I did the other minimum. So here is my minimum. Here's another minimum. Those would be the answers, rounded to 3 decimal places. You don't have to write the whole thing. And here's the maximum. And these are all points, right? They're all points. Now this is the way to do it with the function. You can do it also with the derivative. Okay. Okay, so if you're curious about the second graph on your notes, it's because you can do the exact same thing. Well, kinda. You get the same exact answer, but a different way if you were to actually derive this function. If I derived this function, I would get 0.8x cubed minus 2.1x squared minus 4x plus 5. That is what I would get if I were to derive this function. Now, I'm going to graph it. Okay, so y equals, and I already put it in, right? And graph. And there's my graph, and this is the graph that you have on your paper as well. Now, for derivatives, when you graph a derivative, the slope is equal to 0, but for the derivative, that's the y value. The y value is 0. So here, the y value is 0. Here, the y value is 0. And here's the y value is 0. So since this is the derivative, it's not going to be the min or the max. That's the original. And we're going to get more in depth to that with that in the next chapter. But for derivatives, the slope is 0. The y equals 0. So for the calculator, you're going to find the zeros. All right, so you go to second calc, and it's number 2, 0. And it's going to ask you the same questions as before, left and right. So I'll do 1. So I'm going to do the one I did first for the other one. That's the left. And it's the right. I don't have to take a guess. Hit enter. And there's my 0. And there's my, my x value. All right, now notice. My x value is the same. The y coordinate is not the same because this is the derivative. Okay, so at least I have my x value. If I go back, That is negative 1.862222. Here it is, right? But this is the actual y value. If you do the derivative, you're going to have to plug in the x to figure out the y. Okay? That's the difference. But those are my answers. I just didn't write them out. All right. So here are all the answers written out. Next. Number 8. Here it's asking, does the curve y, blah, 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 have any horizontal tangents? If so, where? Okay, so the simplest way to figure out, are there any horizontal tangents, is to take the equation, derive it. So 4x cubed minus 4x. And then once you have your equation derived, or the derivative, you're going to set it equal to 0 and figure out, okay, what are my x values? So I see that there's 4 and x in common for both of these terms. So I'm going to factor that out. That's the GCF, the greatest common factor. And I'm left with x squared minus 1. Use the zero product property. 4x equals 0. That means x equals 0. And then x squared minus 1 equals 0. That means x squared equals 1, which means x equals plus or minus 1. So my horizontal tangents are at x equals 0 and x equals positive 1 and negative 1. It didn't specifically say the points, but you know, what the heck? We can just find the y values. That means I would just take the function and I would plug in 0, and when I do, I get 2. I would plug in 1 and I get 1, and I plug in negative 1 and oh look, I still get 1. And so the curve has horizontal tangents at x equals 0, 1 and negative 1, located at the points 0, 2, 1, 1, and negative 1, 1. So it's all written out. The curve has horizontal tangents at x equals 0, 1, and negative 1, located at the points 0, 2, 1, 1, and negative 1, 1. Okay, please do your homework, and remember, there is a quiz. It's going to be on derivatives. I'm doing product rule and just deriving regular equations.